Hey guys, Mrs. Weekly here. Don't feel like I've talked to you in a while. So, welcome back. We are going on into the next standard. And this standard is dealing with systems of equations. You should have already watched the Ed puzzle where it walks you through how to use the graphing strategy. If you have not watched that, stop here, go back to watch that. That was the first thing you were supposed to watch today. The next thing is what we're going to be doing kind of as your activity. So, with your activity, you're going to see different problems like this, where there's like little moles. It's supposed to be like a whack-a-mole type of thing. But you're going to have the two equations, just like the video kind of showed you. And in those two equations, I'm going to kind of go through an example so you know how to show work, how to graph, all that good stuff. Okay. So always when you're going to graph both of these lines, okay? So these are two different lines here. So you want to make sure that you're graphing each one of them separately, okay? So there's two different ones, graph each of them separately. So when you begin, my suggestion to you in order to graph, as long as it's in this y, oh, it's not letting me go, y equals mx plus b, so that slope-intercept form, as long as it's in that format, I can go ahead and graph right away. Okay, so I always start with the y-intercept. So in this case, my y-intercept is this plus 2. So that means I'm going from the origin, I'm going up 1, 2 on my y-axis, and that's going to be my first point. Okay, so once I have that first point, then I'm still on the same line, so I'm not looking at the other equation yet. I'm moving on to the slope. So the slope in this case is negative 1/2. And when I'm doing that, I know that slope is rise over run. So that's telling me from that y-intercept, that's my starting point, I'm going, so since it's rise and it's negative, I'm going down 1, and then, so I'm down 1, and then to the right 2, because that's like a positive 2. So that would be the next point. Okay, I can keep doing that, and I need to keep doing that because the more points I have on my line, the better. So I'm going to keep going from that point and going down 1 to the right 2, using that same pattern. I could go down 1 to the right 2, but that kind of gets me off my graph. So I'm going to go from the y-intercept and go the exact opposite. So I'm going to change this to a positive 1 and to a negative 2. Okay, the exact opposite of both of them will go in the same direction. So that means I go up 1 and then to the right 2. Or sorry, to the left 2. Up 1 to the left 2. Notice how that just continues that line. Now, my next part is to connect all of those dots. Well, you'll do it a little bit better because you'll be using a line tool. And then after that, I'm done with that first line. I need to go on to the second line. So again, this next equation, I'm going to use green for this one. This next equation is in this y equals mx plus b, but this plus b for my second equation, if there's nothing there, it's like a plus 0. So I'm starting at the origin for this next line to graph. Okay, so remember this is a completely separate line, has different points. So starting at the origin, that's my y-intercept because of that plus 0. Then I move on to the slope. So the slope for this one is 1/2, but they're both positive this time. Okay, so that means, again, rise over run. And that's telling me to go from that green point I put there, up 1 to the right 2. Okay, up 1 to the right 2. The most important part with these systems of equations is to make sure that I'm getting enough points, okay? The more points on your line, the better. So again, I'm going to come back down because I'm going to get off my graph if I keep going to the right. I can do the exact opposite. So I can make that negative 1 over negative 2. So from that origin, I can go down 1 to the right 2. See how it's kind of like going through the moles? Kind of gives you hints there. Down 1 to the right 2. Okay, so now that I have enough points, I'm going to connect them, obviously do the better job than that. But you can see that it hit at this particular point. Okay, that's where the lines intersected. So in this case, there's going to be one solution. Okay, so the one solution is an ordered pair. Okay, make sure that you are counting correctly. So remember, it's always the x value and then the y value. So I'm going 2 and it went up 1, so to the right 2, up 1, so that's a positive 1 on my y. So my solution should be 2 comma 1. At this point in time, I have to check that. Okay, so I'm going to get rid of this stuff right here. All right, so when I go to check, I'm taking my original equation and I'm substituting in the x and the y value that I got as my solution. So for the first equation, it says y. Well, y is 1, so I'm going to substitute that in right away. So 1 equals, and then I have that negative 1/2, so negative 1 over 2, times x, which x is 2 from the solution I got. So I'm going to put that 2 over 1 just because I'm dealing with a fraction. And then I still have that plus 2 as part of my original equation. Okay, so now I'm going to go ahead and multiply. So negative 1 times 2 gives me negative 2. 2 times 1 gives me 2. So that's going to give me a negative 1, but then I still have that plus 2, and I have equals 1. Well, does negative 1 plus 2 give me 1? Yeah, so it does check out for the first equation, but I also have to do this for the second equation. So I'm going to do that for the second equation as well. So the second equation started with y, so y I know is 1 according to the ordered pair I have. And then this one has a 1/2, so just a positive 1 over 2. And then times x, okay, and it doesn't have anything, you don't have to put that plus 0, that was just to help you graph. So I have plus x, which I know from my ordered pair is 2. Again, I'm going to put that over 1. So when I go to multiply, I'm just going to bring down the 1 equals. So 1 times 2 gives me 2 in the numerator. 2 times 1 gives me 2. Well, 1 does equal 2 over 2 because that's still 1 whole. So as long as it checks out with both of the original equations, you know your solution is this 2 comma 1. Okay, it's always going to be an ordered pair. All right, so if you are looking at the activity that's posted, it is a slides activity, not a Jamboard one. So all I did was just copy and paste what I just showed you on the first slide, so you have that example. So your job here is to do the same kind of thing. Okay, so I'll show an example using the slides now. So you may want to use, so like these drawing tools are from Screencastify, they're not on slides. You may want to use a piece of paper for this part. So first thing I'm going to do, and I'm just going to show you kind of what I'm thinking. So I know that these are in that y equals mx plus b format because y is by itself. So this 4x, there's no plus b, so I know that that's 0. Okay, so it's like a plus 0. That's, again, starting with my y-intercept, which in this case is that plus 0. So I'm starting at the origin to graph my first equation. So from the origin, I go to my slope. Well, my slope here is a positive 4. Okay, so I have 4. Anytime I have a whole number, I'm going to put it over 1. Okay, remember you always want a fraction to have that rise over run. Okay, so I'm thinking these are both positive. So from that starting point, from 0, from the origin, I'm going up 4. So 1, 2, 3, 4, and to the right 1. That's my next point. Okay, if I were to do that again, I would go off the graph. So I'm going to go back to the origin and do the exact opposite. So I'm going negative 4, negative 1. Okay, exact opposite of both. So down 4 to the left 1. And that's all I can fit on the graph that's here. Otherwise, I'd be going off. So at this point, you won't have this drawing tool. So you'll be taking these points here and saying, okay, I'm starting at the origin. And I'm just going to drag and drop these basically. Starting at the origin, you're using that slope. You went up 4 to the right 1. And then coming back down because you don't have enough room, you are going down 4 to the left 1. So now, well, maybe. Gotta drag them, right? So make sure they have those 4 arrows, otherwise you're just enlarging it. Okay, so now I have those 3 points. Now you're going to go up here to this line tool. Make sure that you are choosing the line, if I could get it. And you're going from this point to this point. So when I drag that up, that will make your line there. Okay, so normally you would have arrows on these, but it looks like, I don't know, can I put that on there? It's just making one arrow. Okay, so I'm good with that. Normally, just keep in mind you have these arrows on there on the lines. So now with the next one, I'm going to go graph that one. Again, I'm going to show kind of what I'm thinking. This is something that you might want to do on paper. So again, there's that +0 because it doesn't show that y-intercept. So again, I'm starting at the origin. So I'm going to place a dot there, drag it over. I'm going to use a black one this time. So starting at the origin, and my slope here is remember if there's no number there, you can put like a 1 there. So that's really like saying -1 over 1, because I can always put it over 1. So now I'm going to use that slope, and I'm going to drag some black dots over there. So I'm starting at the origin one more time, and I'm going down 1 and to the right 1, because that denominator is positive. So take another point, going down 1 to the right 1. Remember, the more points, the better. Now that I can kind of see my pattern, I can keep going down 1 to the right 1. And then again, I want to keep going up. So I'm going to do the exact opposite. So instead of going down and then to the right, I'm going to go up and to the left. Same thing again, up and to the left. Notice how from my starting point, it kind of changes every time, just using the last dot that I used. So up and to the left. Okay, so now I can go up to that line tool one more time and connect them. You can just drag that over the dot you want until it kind of highlights like that with that purple. Okay, so now you have your dots connected. Okay, it's not going to be 100% perfect. Notice how it's not going through all the dots, but we know that it's supposed to be going through all those dots. It's just my dots aren't perfectly on the grid. Do the best you can with this. I know it's not going to be perfect. So now at this point, I'm looking at where those lines intersect. Well, they're intersecting at the point 0, 0. So my solution here would be 0, 0. Again, remember it's x and then y for ordered pairs. Okay, so that is a 0. My stylus is just not wanting to work. Okay. So again, to check, you're going to look at both of your original equations. So I have y, which in this case is 0. So I'm just substituting in right away. So I have 0 equals 4 times whatever x is, which in this case is, again, 0. Well, then I can actually work this out. 4 times 0 gives me 0. Well, does 0 equal 0? Yeah, it works out. So it works for the first equation. Now I got to go on to the second equation. So again, I start with y. Well, y in this case is 0. So I have 0 equals -1 times x, which is 0. Well, -1 times 0 gives me 0. Bring that down. Well, 0 does equal 0. So I know that 0, 0 is my final solution. Okay? Hopefully these examples helped. Once you do these 4 examples on the slides here, you can move on into the IXL practice. All right? Let me know if you have any questions, and I'll be glad to help you out. All right? Have a good day.